My name's Andrew Johnson, and I'm going to be talking to you all today about how to be choosing a workflow engine for Hadoop. So first off, just a little background about me. I'm currently a software engineer on the data platform team at Stripe, managing our big data infrastructure, Hadoop, Redshift, all that kind of stuff. I've been working in this space with Hadoop and big data for a little over 5 years now. And I suppose most notably for this talk, in that time I've run and managed several different workflow engines in production, ranging through just basic cron systems through Oozie and Airflow. All right. So to start off, I want to talk a little about what a workflow engine actually is, so that we're all on the same page together about what we're looking at here. So at a high level, the kind of succinct summary I would give for what a workflow engine is a tool for managing data pipelines, running everything to process your data from start to finish, all of your ETL and such. This implies a number of features that such a tool would have. I'll get into on the next slide here. What I do just want to note is that this is primarily a batch processing space, that's where workflow engines are traditionally designed for, and stream processing has a number of kind of different constraints and tools. So when I talk about this stuff, it's in that kind of batch processing context. So what is a workflow engine? First off, we consider it's responsible for scheduling and running all of the jobs in one or more data pipelines. Takes some definition of this pipeline and runs them all on whatever desired schedule that may be, if that's daily, hourly, weekly, whatever you might have. And also it ensures that they're running in a correct order based on the dependencies that are expressed between them. Such as if you have job A producing data that job B needs as input, the job A will go first so that it actually the second one actually has its input ready to go. So then, given that, it provides a mechanism in some fashion to track all of the individual jobs in these pipelines as well as the state of pipelines as a whole. So you can tell what they're doing, making sure they're running correctly and what's going on with them. And finally, it's going to give you some kind of mechanism to retry or rerun failed jobs or jobs downstream of a failure in case something goes wrong without having to totally start over from scratch. So, we have these features, and that's a nice list of bullet points and all. But why might you want to use a workflow engine in the first place? What a workflow engine in the first place? What's that giving for you? So, when you first start out building data pipelines, I think it's pretty common for people to just use cron. It's installed basically everywhere. It's pretty well understood. Easy to use and administer. So you don't really need to do anything to get going with that. So, for example, you might build out a simple pipeline that looks something like this. Say at midnight, you ingest some data into your Hadoop cluster. Then at 1 a.m., you run some kind of transformation on it to pull it into a more standardized format. And then at 2 a.m., you load that into a database so your users can do some kind of ad hoc queries on it. And this is pretty easy to get going with cron. You can schedule these jobs, run at each of these times, do their thing. That's great. The downside is this is really brittle. There's a lot of ways this can fail. Just as a couple examples, if that first job takes 61 minutes to run, the data is not going to be there in time for the second one to run, and it's going to fail or do the wrong thing. It's not great. And the kind of converse of that is that if it takes 10 minutes to run, you have a lot of idle time when you could be getting your data available more quickly. Also, if one of these fail in the middle, you're going to have to address that failure manually. The cron isn't something that really has those kind of failure handling or retry systems. It's something you'll have to take care of yourself. So you can take cron a step further and start building more tooling on top of it. A common one that I think happens is people add some kind of data dependency framework around this, where rather than just starting at a fixed time, you have crons that wake up every few minutes and see is my input here, and if so, run the job, otherwise go back to sleep, check again in a little bit. I'm going to talk about this more a little bit later on in the presentation. I think this actually can handle quite a few things, but again, there's no other features beyond this. Anything else that you want to build, anything else you want, you're going to have to build yourself. If you want a UI to track the state of all of these jobs, so you can easily see what they're doing and monitor your pipelines, you're going to have to do that. If you want tooling for rerunning parts of pipelines, you're going to have to build that yourself, and so on and so on. And like this is really where a workflow engine comes in that it gives you these features out of the box so that you can focus on working with your data and your data applications rather than the mechanics of running and tracking jobs. So now we have a kind of high-level overview of what a workflow engine is and what you get out of one. And so I want to take a look at the general landscape of workflow engines that are available so we can have some sense of what we're choosing from. So there are a lot of workflow engines out there. There are so many so that I'm not even really going to attempt to list all of them. We could spend all day sitting here listening to me list these off, and that wouldn't be very exciting. And the key is, like, if it can run arbitrary shell commands, there's a pretty good chance that you can use it to run a data pipeline. In fact, I once worked on a system where we used Jenkins, the CI tool, to run pipelines of MapReduce jobs. I know I wouldn't recommend actually doing that. It does in fact work, but there are better options out there. And in the Hadoop ecosystem, given that this is a kind of Hadoop big data focused conference, there's a few choices that I see most commonly used, and these are the ones that I'm going to focus on here. And these are Oozie, Azkaban, Luigi, and Airflow. With the time constraints to talk, I'm not going to be able to go into incredibly great detail about how each of these work, but I do want to give a kind of high-level overview of the architecture of each of these, so you can get a sense of how they operate. So first off is Oozie. Oozie is the original Hadoop workflow engine. I think it's the one like people most commonly think of when they hear workflow engine for Hadoop. It's an Apache project, and it's pretty commonly shipped with major Hadoop distributions, which is another reason it's on the top of people's mind often. And as a result, it's one of the more tightly integrated with the Hadoop ecosystem as a whole. So it has a fairly simple architecture. This is a kind of high-level diagram. There are some more details, but at a high level, you have a central Oozie server that's backed by some kind of relational database for managing state. Clients are interacting with this server over the APIs it provides, and this is for things like submitting workflows or checking the status of things, things of that nature. This server is handling polling for times when it needs to start workflows or pipelines. In Oozie parlance, this is called coordinators. The way Oozie actually executes jobs is somewhat interesting. It runs a map-only job on your Hadoop cluster with a single task that actually then kicks off whatever that other thing might be. If it's another MapReduce job, Pig, Spark, whatever that is. There's a few exceptions where they actually run in the server process itself, but for the most part, it's running things by launching them through your Hadoop cluster. And the next one is Azkaban. This was created by LinkedIn to manage their ETL pipelines on Hadoop. And its architecture is pretty similar to Oozie. I actually believe it started out like almost identically to Oozie's, but as they kind of scaled and grew, they split out the actual execution part of their server from the kind of client interaction and web interface part. So clients interact with the central web server that's similar to Oozie, backed by database, and this is for again for submitting jobs, tracking state, things of that nature. And this server is communicating with the executor server, which is separate here, unlike Oozie, that's responsible for actually executing the various jobs in pipelines, submitting MapReduce jobs to your Hadoop cluster, whatever else it might be. And again, backed by some state in a shared database. So the next one I want to look at is Luigi. This was created by Spotify for managing their pipelines. And it has an architecture that's a lot more decentralized than either Oozie or Azkaban. So here we have one or more Luigi workers that are responsible for scheduling and running tasks. There is a kind of central scheduler or coordinator process, but unlike Oozie or Azkaban, it's not really like kicking off jobs to run. It's coordinating the workers to make sure that we're not concurrently launching two instances of the same job, and it provides the UI to have an overall central view of the state of pipelines across the workers. Things like that. Also somewhat unique to Oozie is that there's no central database or state storage for all the task state. all of the tasks have defined outputs, and it relies on the presence of those outputs. The pattern uses it touches a little success file there to say like this is something that's been successfully run, and it uses those to determine whether or not a task has been run successfully. And then those are in your HDFS or S3, whatever you might be using to store your data. So Airflow is the next one I want to look at, and that was created by Airbnb. It's actually now in the Apache Incubator. It's the newest of these, and so consequently it's been getting a little more press, and it, I guess, is the new hot thing, whatever that might end up meaning. And its architecture is pretty similar to Luigi's. You have a cluster of workers that are responsible for executing the various jobs. Unlike Luigi, however, here the scheduler process is actually responsible for telling the workers to run things. It has an overall view of the pipelines, which in Airflow parlance are called DAGs, for directed acyclic graph. And when various tasks in these DAGs are ready to run, it submits them to the worker and says, you can go ahead and execute this thing. And the worker does whatever it might need to do to run that, if that's submitting a job to Hadoop or something else. Airflow does also have a central database for tracking all of the job state and metadata. And there's then a web server process that has a UI to expose this information for visualizations to end users. All right, so with that high-level whirlwind overview of some of the key workflow engines out there, I want to get into some of the details about how we might actually want to go about selecting a workflow engine to use. So this might be unexpected advice given the title of this talk, but it's totally legitimate to consider just not using one at all. They do offer a number of useful features. There's a lot of great stuff there. But that comes at the cost of having the additional operational overhead of running whatever additional infrastructure you need to actually run that workflow engine. You probably have at least one additional server, a database. If you're using something like Luigi or Airflow, you end up with a kind of cluster of things you have to manage. Not the end of the world, but it's possible that you may not actually end up needing that. And I think the key is to kind of think carefully about like where you are now and what your future needs might be. If you're going to have only a very small number of pipelines with not a lot of complex dependencies, you may not need something really that advanced, and it may not be worth the time to operate some kind of workflow engine. Now, I would still stay away from really basic time-based crons because that's going to make your life pretty painful if you have any kind of problems. And this is where you might be better off just kind of layering some functionality on top of cron, like the kind of data dependency thing I mentioned earlier. In fact, I believe I think Twitter does that for most or all of their processing, and they run at a pretty large scale. So that can actually take you a pretty long way. If that's the way you want to go. Now that said, I do think workflow engines do offer a lot of possibilities as you do scale. So if you do anticipate that kind of growth in the complexity or number of your data pipelines, getting a workflow engine in early can make that a much smoother process. So with that aside, let's say that we do want to use a workflow engine. We want to look into picking one. And so there are 5 things that I think are most important to look at when you're considering workflow engines. Now, I'm going to apply these to those 4 engines that I talked about earlier. But I think these will apply to anything you might look at. If there's some other software out there that you want to use, or if you're considering writing your own for some reason, I think these are things that are important to look at. And then taking the time to think through these up front and see how they fit into your environment will make it a lot easier to find the right engine and operate it effectively in your environment so that you better focus your time on your data and data applications. So these 5 points are: how are workflows defined? What types of jobs are supported, and how extensible is this? And as in, how can you add additional custom job types if you need? How do you track the state of workflows? How are failures handled in jobs and workflows? And then finally, how stable is the engine itself? So I'm going to go through and look at each of these in turn. So the first thing I want to look at is how you define workflows. And so this is specifying what jobs to run, inputs, outputs, for other various arguments, as well as any of the dependencies between them to ensure that the engine runs them in the appropriate order. So this is really what workflow engines are supposed to make easy. And it's going to be one of the most common points of interaction for you or your users. Anytime you want to write some new job and have that start running, you're going to be doing this. And so you want this to be as frictionless and fit as nicely into your existing environment as possible. So there are two broad classes that I see for workflow definitions. And the first are what I call configuration-based systems. And so these systems use some kind of markup or properties language for defining all the jobs and dependencies. And other ones we're looking at here, Oozie uses XML to do this, and Azkaban uses a Java properties file format for this. So I want to look at a little example of each of these. Now the Oozie example was actually too long to fit nicely onto a slide, so I cut it. It would have been, I think, mostly illegible on the projector here. It's very verbose XML. If you like writing XML, you will love Oozie. If you don't like writing XML, then maybe not the best choice. The documentation has some examples. I mean, it's logical XML. It's a lot of XML. Azkaban, on the other hand, is pretty compact. This is a really basic example of just a simple job that would run an echo shell command. It's a properties format, so that's a couple lines. I think the Oozie equivalent of this is probably 20, 30 lines of XML, because you can never have too much XML. Now, the other class of workflow engines, what I call code-based workflow definitions, and these use some kind of full programming language, usually a scripting language, to define these. And both Luigi and Airflow do this, and they both use Python as their language of choice for defining workflows. And so I have a small example of each of these as well. So this is a Luigi example. And so jobs, in Luigi's parlance, they call them tasks, and they define in a class both what to execute as well as dependencies between them. So in this example here, we have a bar task that just touches a file, and we have a foo task that goes through and just prints out something to the log, but depends on 10 distinct bar tasks there. This here is an Airflow example, and in the Airflow parlance, like operator is what they call a kind of class of jobs. Like a bash operator is how you would define any kind of bash shell command. This example from their docs has two of these simple bash commands, printing out the date and sleeping, with the printing out the date depending on the sleep. And so in Airflow, you also have to put all of your tasks into a DAG, or directed acyclic graph, which kind of defines an overall pipeline. So which of these is better? This kind of comes down a lot to personal preference. I personally tend to like the configuration-based ones, but I think there's a few points that are in favor of both of these approaches. So configuration-based systems make it a lot easier to generate these definitions from some other model. Before I've built a system to generate Oozie definitions because no one likes writing XML by hand, and that's a pretty well understood problem. If you have some kind of existing registry of jobs or something, you could generate workflow definitions in XML or properties format fairly straightforwardly. I also think it's a lot easier to statically verify these workflows. Since they're just markup, you don't have to worry about actually executing code to know what the complete definition of a workflow is. You can parse the XML or properties, whatever, do some kind of additional verification on it and make sure that it looks like what you want. On the other hand, the code-based definitions are substantially more compact. So that Luigi example from earlier, in just a couple lines of code, that foo task was able to declare dependencies on 10 unique bar tasks. In Oozie, that's probably hundreds of lines of XML. I'm not sure, but you can do that. You can do this kind of more dynamic declarations much more simply in code because you have a lot more power. And this kind of like dynamic pipeline support is a really strong point of code in that because you can run actual code to define your pipelines, you can do more complex things. And if you have a lot more of dynamic pipelines rather than more static ones, like this is a really powerful thing. And I would recommend using some kind of code-based approach for the workflow definitions. So the next thing I wanted to look at then was what kind of jobs you can support running with your workflow engine. If you choose something that has built-in support for anything you want to run, you're going to be able to get going with a lot less work, and that's great. I mean, other than that said, it is likely you're going to eventually need something custom, so I think it's also good to look at what the extension model is if you want to do something that's not well supported out of the box. Given that this is a Hadoop conference, I think we're all probably fairly interested in support for kind of tooling in the Hadoop ecosystem. Things like MapReduce, Hive, Pig, Spark, all the kind of standard tools. There's some variants here. This is a really strong point for Oozie, given that it's kind of the original here and is pretty tightly integrated into the Hadoop ecosystem. It has really good support for this stuff, and if you're big into these Hadoop tools, you can probably run them out of the box with Oozie. Azkaban is also pretty good. I think LinkedIn uses a fairly wide variety of tools, and the community's added a lot of stuff as well. I think Luigi and Airflow here, I think, have a little less out of the box in that the original authors didn't have as broad a use case in Hadoop as some of the others, and also being code based, there's a little easier to add after the fact. That said, like this is that kind of after the fact adding custom job support is where the code-based engines do really shine. And so this is something that if you have a lot of these, Luigi and Airflow are going to be really strong here. Since the definitions are Python code, you can do whatever, and you can add in some kind of custom third-party API data pull, just right there in line in the task definition, and you're done. And if you have a lot of these, like that's definitely a strong point there. Now, on the other hand, Oozie and Azkaban, since their workflow definitions are not code-based, have a kind of plug-in architecture for adding custom job type support. And so what this means, you have to go and write some Java code, and that defines how the engine should run that job type, and then you deploy that onto the class path for the engine. And this is a lot slower of an iteration cycle for adding these custom job types. And so if you need a lot of these, you're going to be spending a lot more time in that kind of upfront development. Now, the next thing that I wanted to look at was how to track the state of workflows. Once you have your pipelines defined and running in the engine, you're going to want to monitor and make sure that they're actually doing what you think they're doing. I'm going to be talking more about failure in a couple slides. So to start off with, I'm just going to be focusing on just general monitoring, hoping everything's running successfully. So all of the workflow engines that I've talked about, and most of the other ones out there, provide some kind of web user interface for visualizing the graph of all of the individual pipelines and then the state of all the jobs they're in. They're all pretty much equivalent. So this can be a more subjective choice about which you prefer, or if some particular UI fits better into your environment. There's some variance though, and you want to be comfortable with your choice so you can navigate it effectively if you need to find out what's going on. Oozie's UI is pretty dated. It looks a lot like someone took a 1990s Java desktop application and ported it to JavaScript. It's not fantastic, slow and kind of difficult to navigate. And then on the other end of the spectrum, Airflow has had a lot of really strong design work put into it. And so I think it's a lot more usable and easier to jump into and navigate without learning all of the quirks of the tool. And so in addition to those built-in UIs, these engines have various APIs that let you get at that same kind of information that you would get out of looking at the web user interface. And generally, like they expose all the same things. The APIs allow you to get at this in some kind of programmatic fashion. This opens up a number of interesting possibilities for tracking and monitoring pipelines. And the first of these is alternative user interfaces. With Oozie's default being pretty bad, there are several of these that exist. You may have heard of Hue. I think Mbari also has an Oozie UI. And like this is a way to make a tool more usable, or if you have some kind of internal web application framework that you want to integrate it into, this is a way you can do that. And this also allows other kind of tooling like notifications bots. If you want a Slack bot, for instance, to tell you if when a job runs or if it finishes unsuccessfully or something like that. You can do that, and they have these APIs so that you're able to get at the information about the state of jobs without having to just manually review the UI. I mean, depending on what you're looking for, there's a lot of these already out there. There are a lot of open source projects for various kind of bots or alternative UIs for some of these engines if that's something you're interested in. or it's something you can build if you want something that that doesn't exist out there. But I guess it's just good to be aware that like this is a thing that's possible and that you can do this if you want. So, tracking things when they're successful is great because you can always be happy and see a bunch of green and know that things are running. But it's, I think, essentially inevitable that something's eventually going to go wrong. Maybe you have some kind of infrastructure level failure and your Hadoop cluster's down and none of your jobs run. Maybe some bad code gets deployed and something's broken. And then when you have that kind of failure, you're going to have individual jobs that fail, but you're also going to most likely have things downstream of that that either also failed or did not run as a result of that one failure. And so when you've dealt with this, you're going to want to make sure that you can go through and rerun those failures as well as anything downstream so that you can get your pipelines back into the correct state. So with that, the first thing we're going to want to know is do jobs actually fail? Like when does this happen? So all the engines will show you this in their UI. So it's entirely legitimate to when you wake up in the morning and get into work, you can go into the UI and look at everything and look to see if anything's failed. But you probably don't want to do this manually all the time. Computers are great at automating repetitive things like that, and so we can let the computer handle that for us. So you probably want some kind of notification system for failed jobs. So except for Oozie, all of the engines have some kind of hook to send emails or other notifications on failure. Oozie requires you to actually manually add steps for this into your workflow definition, which is not the greatest thing in the world. If you forget it, you're just not going to get notifications. But the others all have this, which is a nice logical thing to have. And so, of course, with those APIs that these engines have, you could also build one of these yourselves if for some reason the built-in functionality doesn't fit well into the kind of notifications you want to get. So now, if we've identified the failure, the next thing that we're going to want to be able to do is actually rerun those failed jobs. And so I should note that all of these engines have some kind of automatic retry functionality already built in. And what this means is you can configure it to, if there is a failure, you automatically retry that action up to some number of times. And this is a great way to handle transient failures or resource unavailability or something like that, and just let it happen. Get retried automatically so you don't have to manually intervene on a failure. If you do have permanent failures, such as bad code in your job that breaks it, and you want to actually rerun something, Oozie and Azkaban have a fairly kind of straightforward imperative model for doing this. They have CLI or UI commands where you can tell it, rerun these particular things, and it will go and do that, and hopefully they work the second time around, and everything's great. Luigi and Airflow, on the other hand, take a different approach, and it's one that I think is actually really powerful in the way that these kind of systems should move, and that they try and treat the individual jobs or tasks as idempotent, meaning that if they run one successfully, the engine can kick it off again, and it will it won't do anything, and it's not a problem to run it a second time. And so what this means for task failures is that you have some kind of task state, and you can adjust this to have the engine kick off a particular job again and let it rerun it. So for Luigi, this is where the job has its output that's defined, and that's an HDFS. And if you clear that output, then Luigi can run the task again, and hopefully that will fix it. Airflow does a similar thing, except that it tracks its state in its database, and it actually has an explicit kind of clear command for doing this. It's the way they want you to do this, of go and say delete this entry out of the database, and then the scheduler can know that it should run those tasks again. So I think this is actually this is an interesting model because it handles a lot more cases than just telling the engine to rerun something. If, for instance, you were to manually rerun a job outside of the engine's framework to fix a problem, then these kind of systems can pick that up more easily rather than just not knowing about it at all. Now, if for some reason you have a lot of jobs where rerunning them is, illogical or wrong, I know, in my experience, this has come up with exporting data to customers automatically that you, even if something goes wrong, you don't necessarily just want to keep retrying and sending things out, because that might confuse them or cause other problems for their systems. And in that model, And in that model, it may make sense that you want to stick with the more imperative, only rerun things when I explicitly tell you to run them that Oozie and Azkaban provide. And so the last of these points that I want to consider in terms of what to look at when selecting a workflow engine is actually the stability of the engine itself. So whatever you choose, it's going to be running business critical data pipelines for you. And so you want to have really high confidence that it's going to do the right thing. Your team's going to be a lot more effective if you can focus on your data and other applications and not about the mechanics of running things and making sure that jobs actually happen every day or hour or whatever. And you want to be able to trust your workflow engine. So all of the engines I've looked at are run in production by large organizations. So none of them are really going to be that terrible. You don't really have to worry about picking one of these and then finding out that it isn't actually capable of running jobs at all or something like that. But there's some variance in general stability given the nature of the projects. Oozie's a lot older than the others, and so it's had a lot more attention over time, and as a result is pretty stable. As an example, like I was on a team that ran Oozie, and for about a 2-year period, we had no unplanned outages with very minor maintenance needs, maybe at most like half a day's worth of downtime in that period. And that's really like what you want out of a workflow engine. Like you just want it to be there all the time and not really have to think about whether or not it's going to work every day. On the other end of the spectrum, there's Airflow, which is a lot newer, and consequently has had a lot of rough edges. I know, this is the team I'm on now. Airflow is the engine we use, and we run into a lot more bugs just because it's a lot newer and hasn't had as much time put into it. Now, that said, I should say, it has improved dramatically, and it's continuing to get better, but it's a little more bleeding edge, and that's a kind of a decision you have to make about how much risk you want to take in terms of bleeding edge with more features or a more stable system. The one thing I would note is if you or someone on your team has previous experience operating some engine in production, that's incredibly valuable and may well outweigh any of these other concerns that I've talked about here. Just because that can get you to the point of having something running and working correctly a lot more quickly than starting from scratch. And so the other thing to consider here is the kind of community support you can get for your engine. If you have the resources to devote lots of engineering time to fixing bugs and adding new features, that's great. You can probably pick anything you want. If you don't have the time, you're going to want some kind of community support to know that if things aren't, if you have bugs or you want features, that there's some amount of work you can get from the open source community. And so again, there's some variance here. Oozie is an Apache project and does also ship with many Hadoop distros. So that gives you kind of two avenues of support there. You have the ASF model for open source projects, and it could be included in a support contract with your vendor if they do that kind of thing. Now, Azkaban and Luigi are still maintained by their original authors, LinkedIn and Spotify. So there you have, I guess, the kind of newer, hipper GitHub mailing list model for supporting open source projects. In my experience, they're fairly active, so that's not like a knock on them that they've chosen this path. But that kind of depends what kind of what you're looking for in terms of getting support for your engine. And Airflow again is in the incubator, so it also has that Apache model. It's not shipping with any distros that I know of, but if it it continues to gain in popularity, maybe that will change. All right, so I wanted to wrap up and bring this all together. So a workflow engine's a really important piece of infrastructure for your big data deployment once you're past a really small scale. But there's a lot of choices out there, and it's not the most exciting piece of your infrastructure. You want it to just work. You want it to be there and not really have to think about it so that you can focus your time on getting insights and value out of your data rather than the mechanics of how you get there. And that's why I think it's important to take the time to think carefully about what choices you have and evaluate what's there. You could make pretty much anything work, but if you can put that time in up front, I think you'll be in a lot better place. So I think we're a ways out from there being a definitively best workflow engine, and just given the nature of software in this space, that may not ever actually happen. So I'm not going to tell you that you should all go and use one specific tool. What I consider important works well may not be the right choice for your environment. I've run several of these in production, and looked at many others. And it's come to, made different choices at different times. Like I said, the team I'm currently on is running Airflow, and that generally worked pretty well for us. On previous teams I've run Oozie, and that worked well in that environment, and been happy with those different choices in those different contexts. And so that's kind of my hope here for all of you, that you can take these points I've raised and make those same kind of evaluations in your environment so that you can get to that same place. And so we have bit of time left, and so I wanted to open it up if anyone had any questions. Yes?
Two questions.
Yeah.
One, if you had to choose a workflow scheduler for a situation where problems are common, the data is missing or the data is bad, which one would you suggest out of that?
Okay.
And the second question is visualization of the workflow. Are there any tools to show the workflow? And for me, for instance, I imagine the thing as a graph. I have an ordered graph, I have priorities on the graph, and I want to basically go through the thing. Can I represent it somewhere? Can I use a graph representative language to see this thing and send it some other program?
Okay. Yep. So the first question there was which of those engines I've looked at that I would recommend in a model, in an environment where data is missing a lot, or things of that nature, lots of problems there. So I can say actually, this is actually something that comes up with my current team. Is we have data that gets delivered irregularly, and we want to kick things off when those things show up. And actually, I think Airflow handles this pretty well. They have something that they call sensors, and they can sense and check for the existence of data, and keep retrying until something shows up, and then start running a bunch of stuff downstream of that, and that's worked pretty well. I know like Oozie, for instance, I don't think has great support for this. I think you might be able to layer Falcon on top of it and get something like that. But yeah. And so the second question was, can you represent the workflows as a graph in some fashion? And all of the built-in UIs actually do that already. That's generally kind of the model that they have for representing the pipelines. Airflow makes that very explicit, and they explicitly call an overall pipeline a DAG, for directed acyclic graph, and they'll have some kind of graph representation in the UI. Of course, you could pull it if you wanted to display that in some other kind of graph tool. You could totally pull that out via the API, or you get it out of their database directly.
Yeah, you could translate XML or any other language into a graph. Just use a graph representation language, and there you are.
Yeah. I mean, so then, in that case, if you're using Oozie, you already have that XML. You can just pull that in. Something like Airflow or Luigi, you're going to have to.
I like XML as much as you do.
Yeah.
Which workflow engine you are using?
Currently, I am using Airflow, and I've previously also run Oozie and a little bit of Luigi.
Where do you move to?
Oh, sorry.
Where do you move to Airflow from Oozie?
So I moved to Airflow because I changed teams, I changed companies. So using Airflow at Stripe, and I had a previous position at Etsy, we're using Oozie. Yes. Yeah.
About scalability, we had a use case where we run around 3,000 jobs per day with Oozie.
Mm-hmm.
So every 15 minutes we were running something, several core
Yep.
Would you suggest anything about scalability? Which one is best in these cases?
Yeah, so the question was about scalability. So I can tell you, that actually is larger than anything I've run through Oozie. With Airflow, we currently run probably 6,000 or 7,000 individual jobs every day. The UI struggles a little bit at that point, but the actual underlying engine for running everything, no problems at all. I think as you get to higher scales, the more decentralized model that Luigi and Airflow offer will probably do better, as you can kind of shard that execution across multiple servers rather than having to scale one thing up. That is I guess another point in Oozie's favor, in the sense that it does generally use the MapReduce task launchers. You can scale your Hadoop cluster and get that kind of scalability as well.
That's other workflow engine supports high availability as Oozie.
So I guess I'll say I'm not familiar with that in the Azkaban case. So I think with Luigi and Airflow, you generally can. The process is you can run on more servers as you need. So if you lose a worker, you have more workers. Spin that back up. Listen, I don't think Airflow's web UI has any kind of HA story, but the underlying actually running tasks does. You can kind of have redundant instances of those, so you're not screwed by losing a single box. Yes.
You consider running many actions, right? More than 100. And also considering multiple clusters and security.
Yep.
What would your recommendation be?
Yeah. So the question there was running large number of actions, then with multiple clusters and security. So I think. If you're talking the kind of standard Hadoop security tools, I think Oozie is probably going to be best integrated there, just because of its relationship with the rest of the Hadoop ecosystem. I will say like Airflow does not have a lot of a security story at present. It just it runs tasks as whatever users you run the worker process as, and there's not currently really an option around that. I know it's something that's in the pipeline, but isn't really there. This is something that I'm not as familiar with Luigi. I think Azkaban. Actually, I don't remember what it is with Azkaban. I would say like if that kind of security stuff is important, Oozie may be a good choice for you there. Yeah.
Are you managing your workflow using a user interface, or it is via some kind of automatic triggering from some application or script? Say example job, creating, scheduling, and submitting.
Yeah. So this does vary a little bit by engine. So like Oozie has what it calls coordinators.
So what I'm trying to ask is, actually we are doing with Oozie, but we are submitting everything via the dashboard. Okay. Sometimes it is not a very efficient way of doing it when we have a lot of jobs.
Yep.
So we are thinking about triggering it via some kind of application key or something like that. So what is my question is, when you compare all these four workflow engines, which will be more suitable if we want to programmatically creating, scheduling, and submitting?
Okay, yeah. So the question was which of these engines is best suited for programmatic scheduling and submission. So and this is something that I've done with Oozie before. Is using its underlying APIs to submit workflows at appropriate times. I find that works pretty well. I think like Luigi and Airflow, I don't think this is something that's as well supported. Like the model with those is that they have their workers or scheduler processes that are just kind of continually running and looking for things to run, and there's not a good of a model for saying I want to submit and run this thing now. So I think that's something that's stronger in Oozie's case.
So in Airflow also you are using a dashboard to submit your job.
Yeah, so like explicitly the way Airflow works is you have that scheduler process and you tell it like you're responsible for these particular DAGs, and it runs continually and looks like are any of the tasks in these DAGs ready to run and runs them when they are.
Thank you.
All right, thanks. All right, and time's up. Thanks everyone.